In this example, we need to find the derivative of this given function as sine theta over 1 plus cosine theta. And we need to find the derivative of this with respect to theta, right? So this is the question. And how do you find this? So as you notice that this given function is actually given in the cosine form, right? So a function at the top and a function at the bottom, or let's say a function at the numerator, a function at the denominator. If that is the case, this is clearly the cosine function. So on that sense, we can actually use the quotient rule. So if you want to use the quotient rule, what is the formula? What is the quotient rule? If you have a function f at the top and then g at the bottom, then the derivative of this with respect to the independent variable will be write down the function of the bottom as it is, multiply by the derivative of the top, minus write down the function of the top as it is, multiply by the derivative of the bottom function, and everything underneath that will be the square of the bottom or square of the denominator. So this is the quotient rule, right? So let's try to apply this quotient rule here to find the derivative of the given function. But if you want to apply the quotient rule, you can clearly see here a couple of information we needed. We need to know what is f, we need to know what is g, we need to know what is f prime, we need to know what is g prime. So why don't we first let's collect those information. So to find the f and g, it's so easy, right? Why? Because f is the function at the top, so f is then the function given over here at the top, or at the numerator is just sine theta, and then function g, which is at the bottom over here, given as 1 plus cosine theta. So this is on the denominator, we can assume that as a function g. So if that is the case, our next goal is to see what is f prime and g prime. Now since both of these functions are given as a function of theta, so we need to differentiate also with respect to theta. So let's try to do that then. So then what is the derivative of the sine theta with respect to theta? The derivative of the sine theta with respect to theta will be cosine theta, right? So let's write that down then. And what is the derivative of the 1 with respect to theta? 0. What is the derivative of the cosine theta with respect to theta? Negative sine theta, right? So if that is the case, we get here our g prime as a simplification. We can just say negative sine theta. So if that is the case for this given the cosine function over here, we have f, we have g, we have f prime, right? And then we have also g prime. So we have all of these necessary information. So I think that we can now apply the quotient rule here. So we need to write down first function g, which we have over here, 1 plus cosine theta. We can copy that. And then we need to write down f prime, which we have figured out earlier, which is cosine theta. We can write that down. Then we have this minus sign over here, carry that on. And we have now f, and which we have figured that out as the sine theta, or we have given, so we can just copy that. And we need to write down g prime, and which we have figured out recently, which is negative sine theta, right? So this is the expression we have at the top, and then everything underneath that is the square of g, and g is 1 plus cosine theta, or the function that we have given on the denominator is 1 plus cosine theta. Take a square of that, and this is the derivative of the given function, right? And we have properly used the quotient rule. But based on this expression that we have over here, it seems like we can also further simplify. So why don't we focus a little bit on that? Okay, so let's try to see if we can simplify this. Let's simplify the top first. So you can see here there is a cosine theta. We can actually distribute by cosine theta to both of these terms, and you can clearly see we get cosine theta plus cosine theta times cosine theta will be cosine square theta, right? We can write that down. And then over here we have negative sine theta, multiply with negative sine theta will be positive sine square theta, and then this is and then underneath that will be square of the cosine theta. So we are done with this again, I mean, as an alternative form of the derivative of the given function. But if you are interested on further simplify, and if you are aware with one of the trig identity, which is cosine square theta plus sine square theta, that is equal to 1, right? So if that is if you know that, we can actually apply that trig identity, and instead of cosine square theta plus sine square theta, we can just write down 1. So then underneath that we'll have 1 plus cosine theta square of that. Wow, we have a nice simplification here, because I see now a common factor at the top and bottom. You can see we have 1 plus cosine theta at the top, and at the bottom we have square of 1 plus cosine theta. If that is the case, we can cancel out the common factor. When we do that, we will have 1 over 1 plus cosine theta as the simplification of the derivative that we have figured out by using the quotient rule. So if that is the case, we can say that the derivative of the given function here is actually 1 over 1 plus cosine theta. And this is the simplified form. I mean, one of you, if you don't want to, I mean, if it's not necessary to find the simplification, you can say this is the derivative, right? And we have a couple of other alternative form over here, but this is this seems like the most simplest form. So we are done with this then.